Hi everybody. So today we are beginning our rank booster series from chemical kinetics. So what do we learn in this series? So we are going to have short videos on the tips and tricks to improve our rank and also to save a lot of time by sharing some techniques for solving the problems. So today's topic is going to be zero order reactions. So let's read the question and I'll tell you how can we solve this question very easily. The question is the T half for a zero order reaction A giving P is 1 R when the initial concentration of the reactant is 2 molar. How much time does it take for its concentration to come from 0.5 molar to 0.25 molar? So whenever you get such questions, already you might know that we can solve this using the integrated rate equation. Apart from that, there is a shortcut that you can use. Now, this shortcut is only applicable for zero order reactions, so please have that in mind. Now, what is this zero order reaction used for? Or what is this trick of zero order reactions used for? For example, let's say that we start with 100 molar concentration of the reactant and it is reduced to 80 in 5 minutes. This is just a hypothetical reaction so that you understand. Now, in the next 5 minutes of the same zero order reaction, how much ever amount of reactant was reduced. So here it has reduced from 100 to 80. That means minus 20 units lost. In the next time interval again, the same amount will be reduced. That means it will reach 60. In the next 5 minutes, it will reach 40 because of the drop of same amount. And in the last one again, it will come to 20 and finally this will come to 0. So the takeaway from this shortcut is for a zero order reaction, equal amount of time will reduce equal amount of the reactant. Let's say there was a drop of 20 units in 5 minutes. After every 5 minutes, you will see the same drop. Okay? Drop. The same amount. Now, this is different when it comes to the first order reactions. So let's try to solve this problem. It is said that the T half for a zero order reaction is 1 R. T half is 1 R. Meaning, we'll start with 2 molar. As T half mentioned is 1 R, it means that the concentration will become half of the initial concentration in 1 R. Now we need to find the concentration changes from 0.5 to 0.25 and the time required for the same. So let's go on. In the next 1 hour, again, please understand that it is a 2 molar dip. Sorry, it is 2 molar reducing to 1 molar in 1 hour. So in the next 1 hour, again, there is going to be the same dip. And it reaches 0. And it reaches 0. But you need a difference of 0.25. You need a difference of 0.25 and not 1 molar. So we will divide both the amount and the time by 4. By 4, which means if there is a reduction of the reactant, 1 molar reactant in 1 hour. Now let's say I divide it by 4. 1 divided by 4 is 0.25. 0.25 molar reduces in 1 by 4 is 1 by 4 hours, which is 16 minutes by 4, 15 minutes. 15 minutes. 1 by 4 hours. Okay. So if I start from 2 molar, which is not required, but just for your sake of understanding, in the first 15 minutes, 0.25 is lost, it becomes 1.75. In the next 15, it comes 1.5. In the next 15, 1.25. And in the next 15, it becomes 1. Moving on, the next 15, 0.75. In the next 15, it becomes 0.5. And in the last 15, which is what is required, it becomes 0.25. So the question is the time required for the reduction of the concentration from 0.5 to 0.25, and the correct answer is 15 minutes, which is option D. So this is a trick which can save a lot of time. So please try this one as well. T half for a zero order reaction is 20 minutes. Then calculate the time in seconds at which the concentration becomes 0.05 from an initial concentration of 0.2. Okay, so let's try with what is given. So from 0.2, T half is 20 minutes means within 20 minutes, it will reduce to 0.1. So what is that drop? Minus 0.1 molar is gone in the first 20 minutes. In the next 20 minutes, again minus 0.1 molar will be reduced because same time, same amount. It will become 0. But we need to stop at 0.05, right? So let's divide both the time and the concentration by half and let's see. So from 0.2, in 10 minutes, I have divided the time by 2. Concentration also will be reduced by 0.1 by 2 units, which means it will come at 0.15. In the next 10 minutes, it will become 0.1. In the next 10 minutes, it will become 0.05. And the question is to find the time required for the reduction of the concentration from 0.2 to 0.05. So that is 10 plus 10 plus 10. And the answer is 30 minutes. 30 minutes. So as I said, you can do the same equation, the question with integrated rate equations as well. But then this is going to save a lot of time if the technique is clear to you. Okay, so stay tuned for the next